Howdy, howdy. This is Mr. Potter. If what I've got on the screen right now looks a bit familiar and a bit ancient at the same time, it's true. We covered the fraction class that we wrote quite a while ago. But what I wanted to talk about today is I wanted to talk about how all of these sorts that we've developed deal with objects. Because when we were doing all of our sorts always involved comparing using a relational operator, using a greater than or a less than to see if the items needed to switch order. And we can't really use less than or greater than with objects. And so I go back to our fraction example because we did write a compareTo method, which allowed us to compare two fractions. And later on, when we start talking about dealing with inheritance, we'll talk about more with how a class actually attains this ability to be comparable. But for our fraction, we had a way to compare our fractions. The idea is I would compare itself to a fraction, and it'll give me a negative number if it is less than what it's comparing itself to. And it gives a positive number if it is greater than what it's comparing to. It returns a 0 if they happen to be the same. So I'm going to use this compareTo to deal with this notion of comparing whether two fractions are equal. And so in this fraction sorter class, what I'm going to do is I'm going to take two of the methods that we've already done. I want the swap because the swap is very important. But for our swap class, we're going to need to make a couple of changes. So I'm going to copy this code, and I'm going to paste it in my fraction sorter. What's different is it's not going to be an integer array, it's going to be a fraction array. But the from and to, these are still indices in our array. These are still box numbers. So these don't actually change. I'm changing from position 2 to position 5, for example. But what is going to change is this temp, because it's not going to be an integer, it's an occupant of a box. It's a fraction. So this is how my swap method changes. So I'm going to need this swap method, and I'm going to take the selection sort out of this. Remember that the bubble sort is probably our least efficient sort, even though it's the easiest to code. It's just two nested loops, an if statement, and a swap. And insertion sort is very, very good if you already have a mostly sorted list and you just want to add a little bit to it, but it's not very efficient if I want to sort a lot of data. So I really want to do this selection sort. The selection sort is nice because it has the fewest swaps. I'm only going to swap at most the number of items in my list. Whereas with the bubble sort and the insertion sort, if I have a particularly bad value, I'm going to be swapping in squared, where n is the number of items in my list. So I'm going to take this selection sort and I'm going to copy it as well to my fraction sorter class. But again, I do need to make some tweaks. The minor tweak here is I need to make sure that this int array is really a fraction array. The more important tweak is this tweak right here. I can't check list sub spot and see if it's less than list sub min, because I can't use less than with the occupants of these boxes. I can't use less than when I'm dealing with objects. And so what I have to do is I have to use the dot compare to, and I have to compare it to the occupant here. And that's going to give me an integer value, and I need to make sure that integer value is less than 0. So this is how the test part of my selection sort changes. So I'm going to compile this just to make sure it works. I'm doing this in the same folder that I had the fraction class. I've recompiled it in the same folder, so I have a fraction.class file. And so now I'm ready, now that I have these helper methods, to go ahead and start my public static void main. And so what I'm going to do is I'm going to start by creating a fraction array called fracs. And that's going to be equal to new fraction. We'll go ahead and make it 1,000 fractions. So I've got 1,000 new fractions. Actually, I don't have any fractions at all. I have a set of boxes that can each hold fractions. I actually need to put a fraction in each one of these boxes. And I need to do that using a loop. So for int I gets 0, I is less than fracs dot length I plus plus, and I'm going to go through and I'm going to create a new fraction. So I'm going to have to create a new numerator. So int numerator is going to get, and I'm going to use the math.random method again, and I'm going to multiply it times 100, and whatever I get out of that, I'm going to add 1, and I'm going to cast it as an int. So the idea here is that I'm going to get some random number between 1 and 100, and that's going to be my numerator. I'm going to do the same thing with my denominator. So I'm just basically going to copy this code and paste it here. And I'm going to say that frax sub I is going to get a new fraction. So I'm using the constructor with the random number num and the random number din that I just created. So I'm going to have a list of 1,000 random fractions. Now, each one of these numerators could be from 1 to 100. Each one of the denominators could be from 1 to 100. So I could have the smallest fraction being 1 over 100, and my largest fraction really could be 100 over 1. So I've got a wide range of values that these fractions can attain. So this is my main method, just starting off creating a list of fractions. And once I've created this list of fractions, now I want to sort. So let me go ahead and use a print method. So I want to print fracs, and of course that means I need a private helper method, just like before. So we're going to do private static void print, again passing it a fraction array, which I'll call list, and I'm going to set up a loop. So for int I gets 0, I is less than frac or list dot length I plus plus, and I want to do system dot out dot print list sub I plus a comma space. And of course, I'm going to have to tweak this because I'm going to run into that fence post problem one more time. So I'm going to make sure I print up to the last element, and then system dot out dot print line list sub length minus 1. So if I have 1,000 fractions, my last fraction in the list is fraction number 999. And so that takes care of printing for me. So now all I have to do is tell it to print all my fracs, and then we'll do the selection sort on my fracs list. and then I will print my fracts again. So let's compile this, make sure I don't have any stupid errors in here. There's one stupid error in there. It says list sub. It's not just sub length, it's list.length, because list.length is the length of the list. I want to take one away from that length and look for that box. That should take care of most of the errors that we have. So process completed, and we're going to run this. So it's going to print out all of my fractions, and then I've got my sorted list. So let me expand this out so I can see all of my fractions. And so I can see this space right here. This is where it stopped printing the fractions the first time. And so I see I've got 72 over 91, 8 over 73, 59 over 88, 52 over 70, 12 over 25, 14 over 77. A whole bunch of fractions. There's a 1/2 right there. There's another, or excuse me, there's a 1, there's a 1. Here's an 81 over 33, so there's a fraction that's bigger than 2. And then I told it to sort, and so look at my smallest fractions. 1 over 99, 1 over 99, 1 over 91, 1 over 81. And if I look down here at this farther end, here's 24 over 32, so that's really 3/4. If I keep going, there's 91 over 90, so it's just slightly more than 1. Here's a whole bunch of 1s that we have. If I look at the end, here's 100 over 2, so that's 50. There's 63, and there's 80. So it looks like we have indeed sorted 1,000 fractions. And if you notice that the time that it took to actually sort those fractions was pretty much the same amount of time as it took to print these fractions. Let me run this one more time. So see, it's printed all those fractions, and there's hardly a pause. It just immediately goes to printing the sorted list. And again, in this sorted list, right after this line, I see 1 over 74, 1 over 72, 1 over 70. The fractions are very small, but the denominators are getting bigger, and so that means that the fractions value is getting bigger. At the end, I've got 76, 77, 87, and 93. So I've got really large whole numbers, essentially, written as fractions. So I've got a real nice idea here. The idea that I can sort objects the same way. Now, because I'm using this compareTo in my selection sort method, this allows me to sort any fractions that have a compareTo method. So strings would also work. I could make random words, and what happens is when I sort strings, it's going to put them in dictionary order, alphabetical order, based on the Unicode values of the characters. So all my capital A's would come first, then my capital B's, my capital C's, all the way to my capital Z's, and then my lowercase a's would start, because lowercase a has a Unicode value of 97, which is larger than capital Z, which I believe is 91. So this allows us to sort any object as long as it implements this comparable method, a way to compare values and return a negative value if it comes before, and a positive value if it comes afterwards. So once again, this is Mr. Potter. Thank you for watching. Have a great day.